test I take, I get an A. Yeah, screaming that's none. When I pulled out the lock, that's done. Doing my thing, homework all day, every day. Triggers is it, triggers is it, triggers is it, triggers is it. Seeing Mr. Ng's face during period 3. Triggers is it, triggers is it.
Hey guys, let's go over 1.75, solve a quadratic inequality algebraically. I'm going to go to dark mode. Question number 1, do this with me and then pick either 19 or 20. Gardening. Marcus is planting a garden. He has enough soil to cover 104 square feet and wants the dimensions of the garden to be at least 5 feet by 10 feet. If he wants to increase the length and width by the same number of feet, by what value can he increase the dimensions of the garden without needing to buy more soil? Create a quadratic inequality and solve it algebraically. So let's go ahead and draw a picture. So here's my picture. We know that this is 5 by 10. And we want to increase it by the same amount, same number by feet. So I'm going to call that one x. Okay, so there is the blue area is going to be what we're trying to increase it by. Okay, so if area is length times width, and let's just call this one width, so this would be 5 plus x, or x plus 5. In this whole new area, we'll call length, that would be 10 plus x. And we want this area to be 103 feet. And we want the right side of the equation to be smaller than. Now again, you might say, Mr. Ng, you just wrote greater than or equal to, but remember, you're going to have to read this right to left. The right side is smaller than or equal to 103 feet. Okay, I'm going to box this one and star it because this is our inequality. And I'm going to do step number 2 here is we're going to try to solve this. And in order to solve, I'm going to have to distribute those two binomials. And to do that, I'm going to use the box method, which is essentially the same thing as FOIL, just multiplying binomials here. 10 times 5 is 50. 10 times x is 10x. 5 times x is 5x. And x times x is x squared. So the right side of the inequality is going to be x squared. We add these together now, so that'll be 15x. And this one will be 50. And then I'm going to go ahead and subtract 103. And we're going to get 0 because, let's write that. Solve quadratics by setting what? Setting equal to 0. Okay. And I believe this is going to be negative 53. I realized that it's 104. And this would give me negative 54. Okay, how do I solve the inequality? Well, the easiest method, but won't always work, is to factor. So let's go ahead and try factoring this. So this is A, B, and C. So A times C is going to be negative 54. My B value is 15. And the factors of 54 are 54 and 1, 27 and 2, 3 and 18, and 9 and 6. And I see 18 and 3. We need to multiply those to be a negative, so one of these has to be a negative. I'm going to choose negative 3 because if I do 18 minus 3 equals 15. Now, if you haven't noticed, we have a quote-unquote trick. Well, not trick, observation, or shortcut. We had said that if you're factoring something that has an a value less than 1, then all you have to do is the x in factoring. You only have to use the box, or x and the box, when a is greater than 1. If you're not sure, go ahead and just use the box and you'll get x plus 18, x minus 3. Okay, to solve, I'm just going to set each of these equal to 0. It's called the zero product rule. One of these binomials has to equal 0. And you get x equals negative 18 and x equals 3. Okay, let's go ahead and plot the solutions on a number line. And I know the parabola is facing up because we have a is positive. I know the c value is negative 54. And in pink, we just had 3, and let's say this is 18. So my parabola is probably going to look something like this. Okay? Okay, what we need to do now is test the intervals. Test the value from each of the intervals. And now we'll do that, hopefully color-coded. I need to pick a number far out here, and I'm going to pick 20. You could have picked at 19, you could have picked 100. I chose 20 because when I think it's just easier to multiply. I'm going to pick a number in between to test, and I'm going to pick 0. And on the far right side, I'm going to pick, over here in the green region, I'll call it, I'm going to pick 4. So let's go ahead and test this inequality. You can use any of the inequalities. What I mean by that, you can use a star boxed, or you can use this one down here, the second starred one. It doesn't matter which one you choose to use. I'll use this one, because I can do some magic. All right, we're going to do this 3 times. Okay, let's go ahead and test 20. Okay, you have 30 times 25 is greater than or equal to 104. Obviously, it's going to be a very big number, and that big number cannot be smaller than 104. Let me go ahead and multiply that. That's 750. Is 104 bigger than 750? This would be false. So we would say no shade. So in this region, I'm just going to write the word no. Okay, let's do the orange region of 0. So this would give me 10 times 5, which would give me 50. And is 104 greater than 50? That is true. So yes, shade. So our shaded region would be here. And the last one is the green region. All right, so I have the green region is 4. So this would give me 14 times 9, which would give me 126. And is that true or false? That would be false, so no shade. Okay, so I'm just going to write the word no. So let's get another color in here that I have not used. Let's try purple. And let's make it a little bit thicker. Chose the wrong one. So basically my solutions here are here in purple that I'm drawing. So as an interval notation, I can have an answer between -18 and 3. And I'm putting brackets because it includes that solution. That should have been -18. But because it's a closed circle, it's a bracket. Now this is kind of weird. I'm going to label this my fake answer. It's a fake answer because it is an answer to the algebraic, but it is not a real answer to the real world. Okay, let's think about this. If I put in -18 for x, -18 plus 10 would give me -8. Can you have a length that is negative? In the real world, that is not real. That doesn't make sense. You would a negative x value is basically decreasing the length of your flower bed or whatever garden is. Does that make sense? So that means the real thing is I want a number that is not only at 0, I want positive numbers. So the parentheses means do not include 0. So don't pick 0 because it's not going to do anything. I guess it's equals to, but it's not really changing it. And I'm going all the way up to 3. If I go past 3, it would require more dirt than the 103. Okay, the next one is called an inequality, or a fancier way of saying that is called set builder notation. If I want a number that is, smaller than 3, smaller than or equal to 3, but I want the same number, pay attention, to be greater than or equal to -18. Okay, you might ask, reading from left to right, that says -18 is less than or equal to x. But remember now, this is a compound inequality, so you can write it just like this. X is bigger than or equal to -18. Notice how that inequality is pointing to the -18, so when I put these two inequalities together, the inequality has to point to whatever you have there. In this case, they're pointing, it's pointing to the -18, and then x is less than or equal to 3. It's pointing to the 3. So in your compound inequalities, you'll notice the inequalities are always going one direction. And then this one, I just want one that is greater than, well, a real world, which just means I want smaller than 3 but bigger than 0. And to make this set builder notation super fancy, I think inequality interval notations is simple enough. In the set such as x can only be between bigger than -18 and bigger than 3. And so I'm trying to point out here in what I'm drawing in white is this is what makes a set builder notation. Okay, so we can increase the bed size by making an x value that's greater than 0 and less than or equal to 3. Number 19, fencing. Vanessa has 180 feet of fencing that she intends to use to build a rectangular area for her dog. She wants the play area to enclose at least 1,800 square feet. What are the possible widths of the play area? Okay, so if I draw myself a picture, the 180 feet is, I want you to recognize that it's perimeter. I'm going to draw a quick visual, right? If I put this fencing and I kind of just go around and go around and go around, that pink one is essentially perimeter. So a perimeter of 180. And what is perimeter? Well, you have width, you have width, you have length, you have length. You just add all of those up and you'll get 2 times the length plus 2 times the width, right? Just combine like terms. Okay. Then when it says a play area, right? Play area, area is length times width, right? She's saying this whole blue area, we want to be 1,800 square feet, which is really large. It's like bigger than my house. Must be a big dog. And at least means we want more than, greater than or more than 1,800 square feet, if that makes sense, okay? So what can I do here? I want the area to be greater than or equal to 1,800. So in some ways, I want 1,800, I wrote it kind of backwards, but it's pointing towards the 1,800. Length times width to be greater than or equal to 1,800. Okay, so what we're trying to do here is get a quadratic inequality. And you'll notice I have 2 variables, actually kind of like 3. Now, this one has 2 variables, length and width. This one up here in pink, if I just, if I do a substitution here, if I put in P is 180, then I get 180 equals 2L, let me erase that, 2L plus 2W. And the question did say, let's go back up really quickly, what are the possible widths? So I want to solve everything in widths or W, okay? So we want to get rid of length. And to do that, I'm just going to solve for L in terms of W and put it into the blue equation, okay? Let me show you how to do that. So if I solve for L, meaning getting L by itself, I'm going to subtract 2W. These are obviously not like terms, so I can't get 178. So it would be 180 minus 2W equals 2L. That's an L. And then here I'm going to divide by 2. And this is going to get me 180 divided by 2 is 90. Negative 2 divided by 2 is negative W, negative 1W, and this becomes just L. Okay, so this is what I wanted. Why did I want this? Because then I can put this one in here, and if I do that, it's going to eliminate the L, if that makes sense. And all I have is just the W. Does that make sense? So these are called systems of equations. When you have 2 variables, there's multiple methods, and this is one of them. Okay, to get a quadratic inequality, all I have to do now is just to distribute. So let's go ahead and distribute 1,800 less than or equal to 90W minus W squared. So I'm going to box this one. I don't know, double star. That's the inequality that we have. Okay, how do you solve this inequality? How do you solve for W? Well, pretend the inequality sign is gone, and we're just going to use our methods of solving. So I want to set it equal to 0, so I'm going to subtract 1,800 here. And then I'm going to put everything in order. Oh, made a mistake. Did you guys see my mistake? Right there. That should be 90W. No, that was right. That was right. Okay, so I have negative W squared plus 90W minus 1,800. Okay, so let's go ahead and, before I try to factor, I'm going to make factor on -1. I'm doing this because, and all the signs will change, if you notice this. I always want a value to be positive. I always want the a value to be positive. Because inside, then I can do the a, b, and c. I can try to factor this. Let's try to factor this. A times c, again, we're inside the parentheses, is 1800. And b value is -90. There's a million possibilities, but I want you to start thinking about numbers that add up to be 90. You can do like 45 plus 45. You can do 60 plus 30. And there, when you're just writing it out, you'll recognize that if I do 60 times 30, it gives me 1800. So I'm going to write 60 and, whoops, 30. And in this case, I'm going to make both of those negative. Negative 60 times negative 30 gives me positive 1800, and if you add those together, you get -90. So our answer is 60 and 30. Now remember, we talked about how the shortcut is if your a value is 1, right? A value is 1, then you just have to use the x. When a is greater than 1, that's when you would use the x and the box. If you don't believe me, go ahead and do the box and you'll see you get the same answer. Okay, now to solve, all I have to do here is just set them equal to 0. Now set each of these equal to 0. And I want to show you guys that, can -1 equal 0? No. So basically that -1 means nothing. All it does is just our graph is opening down. This is add 60 to both sides, we get 60, and 30 is our answer. Okay, let's get ourselves a quick graph. And it looks like we're just working on the left side here. Let's say 30, 60, and in the original equation, I'll just highlight one of these. I think this one's probably the best one right there. We have -1800. And then our graph's probably going to look something like this. Okay, so now I need to test the regions. So let's go ahead and test these regions. So this, I'm going to pick 0. Pick some number in there. Let's pick 40. And a number greater than, you could do like 61 or something like that. What did I just say? 61. Come on. And again, you could choose any of these. I'm going to choose, I'll tell you what it's trying. It's not wrong. You could choose any. I'm going to choose the white box one. No, I didn't want that one. I wanted this one. Because I think the reason why is, again, none of these quadratics would be wrong, but I like it because I can just quickly subtract the value. Does that make sense? I can just subtract from 90 and I get a smaller number. Does that make sense? I hope so. Okay, so I did it here 3 times because we need to test the numbers. And let's just make, let's just make all of these white, and that way you can see my colors. So let's start with 61. 61. Do you see why now? I guess I'm still going to have to use a calculator. So 1800 less than or equal to 29 times 61. 1769. So is 1800 smaller than is 1800 smaller than 1769? This is false. Okay, so that would be a no shade. So no. Let's test the blue region. So I put in 0. And you get 1800 is less than or equal to what? 0. Is that true or false? That's a 0. Pardon. False. No shade. That means my solutions are not in there. Let's double check. Let's pick 40. So that would be 50 times 40. 1800 is smaller than or equal to 2000. And that is true. Shade. Okay, so my solution is there between 30 and 60. Let's get a color. We don't really use yellows. Let's try to use yellow. Is that yellow? I think so. Okay. So let's make that clear. I can go between 30 and 60 is my solution. So interval notation, we have between 30 and 60. And I don't have to worry about it being a negative number, which is kind of nice. And then set builder notation, I want numbers that are less than or equal to 60. But I also want them to be bigger than 30. And then if you wanted set builder notation, all values of x such in this set right here. Okay? And that's our answer for number 19. See you guys later. Bye.
All right, question number 20. A bicycle maker sold 300 bicycles. So I'm going to start coordinating my information with the number of bikes. Is pink. So 300 bicycles last year at a profit of $300 each. So price of bikes, I'm going to keep track in blue. The maker wants to increase the profit margin this year, but predicts that each $20 increase, so $20, is money, which is going to be blue, and increase here I'm going to write is plus 20. That means increase. Will reduce the number of bikes sold. So reduce is subtraction, and this represents the number of bikes, so that would be a minus 10. How many $20 price increases can the maker add and still expect to make a total profit of at least $100,000? We did a problem very similar back, I believe in lesson 1.1 or 1.2 about the ski trips. Okay, so let's make an equation here based off the information we have. So the number of bikes, we're going to start off with 300. And the number of bikes decreases by 10 for every increase. So x represents the number of increases. Okay, for blue, let's talk about, what did we say? Blue was the price per bike. So we start off at $300, and we're going to do add $20 per every increase. How many $20 price increases can the maker add and still expect to make a profit of at least? So we want the number to be greater than or equal to $100,000. Remember, I'm reading that from right to left. Whatever the number of increases is bigger than or equal to $100,000. Okay, what's the first thing I'm going to do here is I want to solve this quadratic, and in order to do that, I'm going to have to first multiply these. So I have 300 minus 10x and 300 plus 20x. Let's go ahead and just multiply in here. So this will become 90,000. You'll notice the number of zeros. 1, 2, 3, 4. 1, 2, 3, 4. 300 times 20x is just 3 times 2, so that's 6. And how many zeros do we have? 3 of them. So that'll become 6,000x. 300 times negative 10x is negative 1 times 3 is negative 3, and there are 3 zeros. X. And then this will become negative 200x squared. Okay, so when I multiply all of those, I'm going to get negative 200x squared. These are like terms, so I can add those together, plus 3,000x plus 90,000. And remember, to solve quadratics, all we have to do is just make the set equal to saving image right now, is set it equal to 0. So 0 is less than or equal to negative 200x squared plus 300x minus 10,000. Okay, from here, I have it now set equal to 0. Let's factor out a negative 200. So that would be x squared minus 15x. That's 2 zeros. So negative 100 divided by negative 2 is plus 50. And remember, you can always distribute to check your answer. Negative 200x squared plus 3,000x, negative 10,000. Okay, what I'm going to do here now is just factor inside the parentheses. Factor inside the parentheses. Let me highlight that so you don't get lost. Here we are factoring here. Okay? So A, B, C. A times C is 50. We're inside the parentheses there. B value is negative 15. So if I list out all my factors, 50 and 1, 25 and 2, 5 and 10, and do you see the answer? Okay, so if I make both of these negative, negative 10 times negative 5 equals positive 50, and negative 10 plus negative 5 equals negative 15. So the answer here, so far, and if you remember, our trick in factoring is if that it's A is 1, then you don't need to do the box. Let me say that again. In factoring, we said that if the A value, which is inside the parentheses there, is 1, then you don't need to do the box. Feel free to do the box and you'll get the same answer, x minus 10, x minus 5. Okay, here I'm going to apply a zero product rule, and we basically set each of these equal to 0. $200 can never equal 0, so basically the negative 200 does nothing. X is equal to 10, and x is equal to 5. Let's review what we've done so far. We've written a quadratic inequality. I have that up here where the star is. And then we basically solved it. Now we need to put this on a quick number line. Okay, so since I know that it's opening down, you have something like negative 10,000. And then you have 5, and then you have 10. Graph looks like this. And basically we're just testing the regions now. So which regions or intervals should I test? Well, over here in the white, you pick a number, that would be 0. I want to pick a number between 5 and 10. I'll just pick this region we'll pick 6. And then a number bigger than 6, which would be, let's pick 11. And you can go back up to that star and just compare it to 0. $3,000 times 0 minus 10,000. And let's just use our calculator. Negative 200 x squared plus 3,000 x minus 10,000. Okay, so what I would do is just go to my calculator. I'm going to type in negative 200 x squared plus 3,000 x minus 10,000. I'm going to go to second. Let's check our table set. So second table. My graph says it's starting at 0 and it's going up by 1. And let's change it to ask. So now I'll just press table. And then I'm going to type in the numbers that we had. We had 0. It gives me a negative 10,000 as my answer. So if I actually evaluated all of this, you would get negative 10,000. And is this true or false? This is false. So no shade. No. Let's test 6. Press 6. Enter. I get 800. So that was the blue region. If I put in 6 into, I'm going to get 0 is greater. 0 is smaller than or equal to 800. And this is true. So write the word yes inside there. Basically what it represents is anything in this region, right? And then let's do the green. So the green was 11. Table, press 11, and you get negative 12,000. Negative 12,000. 12,000? 1,200. Well, whatever the case is, it is false. So this area is no. So then my answer in blue is between 5 and 10. So how do I write that? My values have to be greater than or equal to 5 or less than or equal to 10. This is my inequality. If you want to make it set builder notation, you put it within there. Or if you want to do that in intervals, you would just do 5, 10. And let's box this as our answer. And that was question number 20.
We doing math today, ain't got time for no games. We doing math today, all work and no play. We doing math today, listen up and behave. We doing math today, we doing math today.